Hey guys, it's been a while, and I've got more stuff to talk about for batteries, my new RV. I'm still here in Connecticut, and I've been through a fair amount of snow and cold, and I can tell you, if you're curious, that the new air, the new air that I'm in, has been faring quite well in that weather. We've had some near zero temperatures, we've had plenty of snow, and it's been fine living inside there, and it's been quite comfortable. And when it's 0 degrees out, I'm burning a lot of diesel, keeping the heat going. I think in 3 days I used 8 gallons. So I've been using we'll come back to the batteries in a second here, but I've been using a couple of 5 gallon yellow diesel gas cans in my truck, and I just haul that back over, and then I use this battery operated fuel pump or liquid pump, but it's capable of handling fuel, to get that from the gas cans into the RV, because it's impossible to do while the slide outs are out, because they basically they end up covering the gas inlet. So not sure what else you want to hear with respect to me just sitting here mooch docking at my parents with respect to the current RV, but if you have questions, certainly feel free to ask. But it's been faring well, and I'll be putting that up for sale after I get the new one. So if you're interested, certainly keep an eye out for that. Anyway, off to, at least for what's me, fun and keeping me out of trouble during everything that is going on, both between the winter and just everything going on with COVID. I really needed this hobby, and this has been fantastic for me to have. And I've been doing lots and lots of revisions. I think the amount of time that I have between now and picking up the RV, which so today is February 20th, I think. The RV, I'm supposed to pick that up in about at the end of March. That might be a little bit delayed due to weather in Kansas, delaying the paint shop. But anyway, so I've got about maybe another 5 weeks or so, 6 weeks or so before I pick it up. And I've been going through lots and lots of revisions and studying and still learning about batteries and the best way to set these up. It's really quite surprising how much I've continued to learn. So here's the current state of affairs. You'll recognize my laptop, perhaps, if you've watched my previous videos, and you perhaps recognize this graph and this Orion BMS. So as I'm sitting here talking, I should probably step back, because those of you who have not watched my videos will need a little bit of a preview for what's going on here. So I have 560 amp hours, 48 volts, or about 28 kilowatt hours of battery configured here in front of you. That's what these 4 packs are. They're not really 4 individual batteries. They are one battery. They're just in 4 separate compression mechanisms. That's what these orange springs are for. And they're all connected to that one BMS. And so this is the battery that I'm going to be putting in the new RV. And connected to that battery are these 2 Victron Quattros, 5 kVA units. So I'll have approximately 8,000 watts, split phase capable, available to me here. And I actually do need split phase in the new RV. It does have a 240 volt mini split in there. Otherwise, I wouldn't necessarily have gone with this particular configuration. But this is how we do split phase for in the Victron world today. And this is going to be the solar charge controller for the 10 335 watt panels. So 3.3 kilowatts of solar will be on the roof. And then there's some additional equipment. You can see the bus bars. There's a DC to DC converter here to go from 48 to 12 volts. And I'm creating a 12 volt system here. And this is going to be the 12 volt side of the RV, and the 12 volt battery here for the RV. And I've got the Victron display sitting here. The Victron Servo is sort of the brains of the entire system. Everything comes together here. And for testing, I've got, this is new if you've been watching, this is a Riden power supply. It's a 6018, so it is capable of 18 amps, 60 volts. If you put a big enough power supply inside the case. I only have an 800 watt power supply in there. You would need 1200 watts in order to get your 18 amps. So I can do about 12 amps off of this, but this is a nice programmable unit. I've got a graph here. It's pretty flat right now. It's not very interesting, but what this is doing right now for me is it's simulating a solar panel So this is providing input to here, and so you can see that it looks like I have 230 watts of solar going in, even though I don't have any solar panels connected. And you might wonder what this is. This is not the panel going on the roof. This is a one of two 200 watt 24 volt panels that I'm going to connect in series so I can do some testing here, do some real world solar testing here in Connecticut, and then these will become my optional ground deployable solar should I need to do something like that. So I will take those with me. And that's kind of the current state of affairs. My current configuration now includes mounting all of the equipment related to the battery, like the BMS is on this side, and on this side there's the main contactor relay, there's the amplifying relay, which is now a solid state relay. This contactor is going to be swapped out when I do receive a new one with one that consumes less power. And then the circuit breaker is down here. So all the wiring is going to get cleaned up. I'm going to be inserting Molex connectors in between so that I can connect and disconnect each set of 4 individually. That'll make managing these easier. I'll find a permanent location for the temperature sensor. I do have one of these cells, the terminals is stripped. There's been a lot of learning in that regard. And unfortunately, it's one of my better cells. It's the cell that tests to 278 amp hours. I was hoping it was going to be one of my bad cells because then I wouldn't care so much about drilling into it. But I do have 4 cells. There's one here and there's 3 more behind the panel that are my worst performing cells. So I'll do some practicing on that. I'm going to drill and tap and put a helicoil kit in there, which is going to give me a new M6 thread inside, which will effectively repair that. So that's going to be quote unquote fun. I've got modified CALB bus bars. These are flexible bus bars. And so I've got these in place now. This creates the parallel connection. I used 2 of them. So this is 1 millimeter by, I think it was 20 across. I actually don't remember now. Plenty of copper here. This normally isn't going to carry any load. So what I wanted to show, what I had just done before I started taking the video was I turned up, I had discharged the battery all the way down to 0 so I can get some proper flattening of the cells and some proper compression happening. And so now I am charging at the maximum that these can charge at. So the theoretical maximum charging output, if you look at the specification here, is 70 amps or 140 because there's 2 of them. So the maximum theoretical charge is about 140 amps. And the number varies a lot because there's just AC, there's a ripple effect that's happening. That's why this graph isn't particularly clean, right? The lines are kind of all over the place. But let's take a look using my multimeter here. We'll zero out the amperage. We'll take a look at the main negative line here and we'll see what's actually happening. So we got about 128.6 in here. And what I wanted to observe is what kind of load spreading do I have happening here. So the way I've wired my batteries is a little different than most. Most people will just run bus bars for the parallel and run another bus bar for series. And that ends up creating a bit of an imbalance between how much is being pulled from this cell versus how much is being pulled from this cell. And so what I'm doing is I'm actually wiring both of these together in such a way that hopefully all the current is pretty well balanced between all of them. So if I do this, I should observe half. So I've got 64.1 amps here, and let's see if I can get a better view of this. 63.5 amps here. So that's not bad. That's, off by less than an amp. So if I do the same thing, 64.3, 63.5, and I've got another set of wires back there joining these two, and it's the same thing. So the amperage is being divided nicely. So what that means is that none of these connections are receiving the full bore 140 amps, which 140 is 0.5 C for these cells. These are 280 amp hour cells, so 0.5 C is actually a pretty reasonable amount of current to charge or discharge these with. So even at full charge, even if I only had 16 of these cells, for example, and I had none in parallel, even at full charge, they were getting 0.5C. But because I have 2 of these in parallel, they're receiving half of that. So each of them is receiving, as you saw, between 63, 64 amps of current, right? So that's only 0.25C. So that's really actually pretty easy on these cells. It's really easy on the wiring. It's really easy on all of this wiring. So this thing is capable of charging at, 7,000 watts. All the while, there's actually not a heck of a lot of current going around on the DC side of things, which is excellent. That makes for a really strong battery, and it means that I'll be able to draw large amounts of power without having to worry about voltage sag or overloads or things cutting off or things getting too hot, the lights dimming, or those sorts of things. So I'm pretty happy with the sort of the strength of the system. The thing that I've been iterating on and struggling over has been the sort of the physical design of the battery, and I'm not entirely sure that this is the final design. I was kind of hoping it was going to be, but I do have Anderson connectors on the way, so I'll be able to cut these and put an Anderson connector in here so I can join the 2 batteries, and that will make these 4 things completely independent. So I can disconnect the Molex connectors for the BMS leads and then disconnect the Andersons, and then I'll be able to have 4 independently movable objects. These are about 100 pounds each. They're pretty heavy, but I can move them if I need to. And the rubber feet and the springs should accommodate all of the compression and expansion that's going to occur. Should be about 4 millimeters from 0 state of charge. And when I get to 100%, I should expand by a max of 4 millimeters. And these will not only provide some cushioning, while I'm driving down the road, but should also allow for that expansion to occur, because I plan to bolt these in. There's a thread inside the bottom of this, so I should be able to bolt in underneath, and that will secure these into the RV quite nicely. So if we take a look at what's happening on the graph here, this is one of the things that I'm wondering about changing. There's 2 lines, the yellow and the green line, that have that are pretty different than the rest of the lines, right? So what's happening is that because these are much longer than these, the resistance of these wires is quite a bit different, and that leads to the graph looking like this. And so at times it looks like the cell is at 3.4 volts, but it's actually not. It's closer to 3.3 volts. Sometimes it thinks it's 3.225 volts, right? So it's not very accurate because of that. And what I've been sitting here noticing as I've been working with these cells is the distance between the terminals hasn't been changing much, even with these flexible bus bars. So I'm going to do a couple more charge and discharge cycles, and I'll take measurements of these. And if these aren't really moving much, then I might actually strongly consider replacing these and these with a solid copper bus bar, and even these. So I would have a solid copper bus bar going across to join these 2. And that would make for less of that artifact. It would make for an even stronger setup, and it would be cut out of this copper, which I've actually had here. I originally intended to use, but I got this tinned, I think this is 1/4 inch copper bus bar that I can cut to length and drill out and all that happy stuff. And now that I actually have a chop saw and a drill press, that's easier, much easier for me to do. I tried to do that before with just a Dremel and a regular drill, and that didn't go particularly well. But anyway, those are sorts of the things that I'm mulling about right now, and the kinds of things that I'm playing with. And as a really brief, despite this being 15 minutes long, a pretty brief update of what I've been up to with respect to the battery system here. So I will put a link in my video description here of the thread that I have on the DIYSolarForum.com site for this build. If you're interested in talking to me about it, or just seeing some of the more details behind it, there's now 350 posts on that thread, so it's a lot to go through. But take a look at the first couple of posts where I lay out some of the details around what the new RV is, why I'm doing this, what the specifications, target specifications are, the electrical diagram, and then you can maybe join the conversation at the end of the thread and just kind of catch up with where things are, if you're interested. So I'm on that forum all the time, and I'll get a notification if you do post, and you can private message me there or leave a comment here. I'm happy to help answer questions, and we'll take it from there. So the days are getting longer. The sunset is now 5:30, and we're headed towards spring, despite the fact that it's currently snowing. And I'm heading towards picking up this RV in 5 or 6 weeks, I hope. So really excited about that. Really excited to show you that. The New Horizons folks are really excited to actually help me get this installed in their RV. They're very interested in this. This is a system that they've never seen a system this capable installed in their RVs before, so they're quite interested in it, and they're going to help me with some of the physical fabrication and probably some welding and whatnot involved in getting like a shelf put in and things of that nature. So there'll be plenty of that to come. It's all right, enough of that. Thanks for watching, and as always, stay safe, have fun, and let me know if you have any questions. Happy to help.